Hello, everyone. Thank you for joining our webinar today. My name is Jody Scollard with Chicago White Metal Casting. I'm going to give just a couple more minutes for anybody else to join the presentation, and then we'll get started. Okay, thanks again for joining today. I think we've got most of the people who are going to join logged in already. We'll go ahead and get started. Again, my name is Jody Scollard. I'm a business development manager for Chicago White Metal. I'm based in Atlanta, so handle a lot of the Southeast accounts. I've been with Chicago White Metal right at 12 years, so quite a while. So I will be stepping through the presentation today, and we'll get started here in just a second. Also on the online are a couple of panelists that you can ask questions to during the presentation. John Miller, our VP of Sales, and Mike Dimitrov, our inside sales manager. We'll show how to ask those questions right here. So if you got any questions, there's a section on your GoToMeeting screen or control tab where you can type your question in, hit send, and we'll get to your questions just as soon as we can. A lot of times questions tend to come in groups or flurries, so please be patient if it takes us a few minutes to get back to you, or it actually may be after the presentation. If there's a lot of questions that come in, we'll continue to answer, and we can send it to you after the presentation's over if needed. So just to give a quick brief summary of the webinars that Chicago White Metal has done in the past, we've covered pretty much soup to nuts all the topics for die casting. We've gone through alloy choices, surface finishing, conversions from other processes over to die casting. So as you can see, there's a pretty wide list of things we've covered. All of these presentations were recorded when we did them live previously, and are located on our website. So if you get a chance and there's a topic that maybe you weren't able to see previously and would like to go back and take a look, log on to our website. You'll be able to find the webinars that were previously recorded, and you can always go back and take a look. Today's webinar, we're going to focus on the medical industry and what people in that industry are doing with die casting, why die casting is a good option for some of the components in the medical device industry, and hope there's some useful information for you. So to get started, just an overview. So why look at die casting for medical device products? There's a good variety of alloy choices. They suit very well to a lot of the needs for the medical device industry. The material properties that are there are good fits. There's a very, very wide range of surface finishes, which is really important for the medical industry. We'll cover that topic in a pretty good amount of detail in this presentation. We'll talk about conversions from other types of processes. Maybe you're using some CNC hog outs or plastic parts or investment casting parts, and we'll take a look at those and how the advantages and disadvantages of converting those over to die casting. We'll talk about prototyping options that are out there for die casting, and then a couple of other topics, some advanced quality processes and packaging. And then throughout this presentation, we mixed in some case studies and specific applications of medical devices that are using die castings, and we can talk about those. Some of the overall product benefits, performance benefits by using die castings: good strength and stiffness and rigidity characteristics. We show us a couple of slides here in a minute of some material properties that we can talk about. Again, excellent surface for cosmetic finishes. Material efficient designs, meaning you get as much, the goal is to try to get as much net shape into a die casting as possible, so that when it comes out of the tool, there's very little to do with it. All your features and things that you need out of the part are already contained in the die casting when it comes out of the tool. Excellent RFI EMI shielding. So this is, again, very important for applications that have electronic circuits or other types of electronics inside the medical device. The die castings are very, very good for shielding interference away from those electronics. All of the alloys that we die cast, the aluminum, magnesium, and zinc families, are 100% recyclable. So obviously that's a big item these days, and that's important. And the bottom item, the look, feel, and durability that metal can provide. So many times there's customers looking to make a part maybe out of plastic, but because of the feel of it or the durability or whatever reason, that there may be a die casting alloy that would be a little better for that application. So here's the first slide for material properties. We won't talk a lot about these. This information will be provided after the webinar, so you'll have all the breakdowns of alloy properties. Just a couple to point out, maybe yield strength. Just take a look at that between the different alloy types. Zinc being a very, very good for yield strength. Aluminum and magnesium being pretty much on par. And then we have a nylon 6, or just a kind of a generic injection molding resin to compare against. So you can see that all the die casting alloys are pretty superior to that. Impact strength is another one I'll point out. Again, zinc is very good for that. This becomes very important, obviously, if you have to do a drop test or any kind of other durability testing on your medical device. That obviously becomes an important factor. The second screen for alloy properties, again, a couple things to point out. When you look at the relative densities of each of the alloys, magnesium is by far the lightest. It's the lightest structural metal alloy out there. Pretty much on par with plastic, actually. They're fairly comparable weights, so a lot of times people are able to convert a plastic part over to magnesium, not affect your overall product weight, but get far better material properties. So magnesium is the lightest weight. Next one is aluminum, which is about 50% heavier than magnesium, and then we go all the way up to the Zamac or zinc families of alloys, which they're in the 2.5 times heavier than aluminum range. So they're pretty bulky parts. So that's important. Understanding the densities of each alloy, relatively speaking, is important. And again, we'll send out this information so that you'll have the entire breakdown of material properties. Here's just a quick comparison that we put together to show how each alloy ranks within the various material properties, strengths, and density, and ability to be processed, that type of thing. Trying to see what in here might be interesting. It's funny that the zinc shows very well on a lot of these categories. It ends up being number one for a lot of them, between die life and thin wall ability and strengths, and so you kind of wonder, why isn't zinc being used more? But zinc, if you remember on the previous slide, is very heavy. So a lot of times the application just can't take the weight disadvantage that zinc has, even though the material properties are excellent. The one thing I will say, that on very small parts, and we talk about that here in a minute, very small parts are actually really good applications for zinc. You can run small, what we call miniature zinc die cast machines, very small machines, run very quickly, and very good for small parts. And for small parts, the weight disadvantage is usually not that big of a deal. So keep in mind, if you've got a small part, potentially zinc is a good option for you. So here's the first case study or product application we'll talk about. This is a oxygen concentrator system. So you'll see advertisements and you'll see people with these shoulder-mounted oxygen systems. So this takes the place of when people used to roll around a large tank and provide their oxygen that they need. So these are very, very lightweight, small applications, actually getting even much, much smaller with new generations. So these are there's actually 6 or 7 very, very small magnesium AZ91D alloy parts inside those systems. And there's, you can see on the screen we show, there's the current model. This is what's buried inside the product. This is actually a small motor, basically, that's generating the oxygen. And then you see highlighted in the background is the previous model. So you can see the size change, and with each new generation, the size and weight are coming down. Challenges for this, obviously, lightweight, corrosion resistance, and so magnesium with an E-coat, the black that you see is an E-coat process, ends up being a fantastic solution for this product. Very, very lightweight, very strong, good corrosion protection, and the E-coat obviously will assist in that. But a really good application for magnesium die casting in a product. The next one here is a Heatsink. So this is for a vitals monitor that you would see in an OR or doctor's office. This is an aluminum part. Challenges here was obviously that the part needed to be fairly lightweight, needed to be very good for thermal conductivity in order to get heat away from the electronics. And so in this case, it was a good choice for an aluminum part. This part gets anodized. You can see it's sort of a brown, lightly black. I don't know how you want to call it, but it's anodized that's applied that helps with corrosion protection and some wear resistance and prolongs the life of the product. So here again, I mentioned earlier that surface finishes are a very big part of not only all die-cast projects, but specifically for the medical industry. It's a priority for a lot of the products. Along with the surface finish, there's a couple of steps. There's a pre-treatment that is usually done on a part, and then a final top coat, whether that be a powder coat or wet paint or another type of process that gets applied afterwards. So it's a multi-layer system typically for the coating. So again, very, very important and something to consider early, very, very, very early on in a project. For the medical device, obviously cleaning, sterilization, there's a number of different chemical solutions that people will apply to their product to clean it in the medical environment. So the coatings that are used have to survive that and be able to hold up over time. No toxic emissions for certain applications. So the previous case study we talked about, the oxygen concentrator, oxygen is actually flowing over those die-cast parts, and then the user is breathing in that air. So you don't want the coating that's on the parts to give off any kind of emissions or anything that's going to affect the health of the patient. So also an important factor, and the thermal electrical properties. We talked about that in the alloy discussions a minute ago, but those are obviously very, very important for the applications. If we look at some of the different finish types, there are 3 categories that we break down into this table. Mechanical finishes, and that meaning shot blasting or glass bead blasting, any type of part-on-part or a media that's blasting against a part. That's what we mean by mechanical. Conversion coatings are typically platings that the parts will go through. These are typical pre-treatments in a lot of cases that are used before the final coating will be applied. But sometimes these chemical conversions are used on their own. So it's if the part is not a cosmetic part and you just want some a plating or type of finish to add some corrosion protection, then a straight chemical conversion process will be fine, and just leave it like that. The last section on coatings, these are usually the top coats. So whether that be an E-coat or a powder coat, electroless nickel, a lot of these are what's considered cosmetic finishes, and so that's the typical top coat that's applied. The highlighted items in this chart are what are more common in the industry and being used a lot currently. Some of these other ones are available but not used quite as much as what's being done currently, but the ones that are highlighted are very common. So just to go into a little bit more detail on the mechanical finishes, or each of the categories we'll talk about. Again, shot blasting, polish and grind, so that if it's a cosmetic finish that's needed, a lot of times we will polish away the parting line of the die casting to remove that from a visual standpoint. Other areas of the part could be polished if it's for a surface finish or other type of requirement. And then there's dozens of different types of bead blasting, whether it be glass or steel shot or many, many different types. And this shows the little image down here shows when you go through this mechanical finishes, what it also does is help remove some of the small amounts of flash that are contained on a die casting. And this shows what could be a before small amount of flash, and then after the mechanical finish, the part is much smoother and the flash is removed. So a couple of different good reasons why mechanical finishes would be utilized. Again, chemical finishes, we talked about this, but these are some of the more common ones that are used. A clear chromate, which is trivalent, so it's RoHS compliant. Iodine, which is another good pretreatment that's being used. A lot of times this is used ahead of prior to the E-coat process, but again, very, very good. Corrosion protection, relatively inexpensive, and a good pretreatment finish. Anodize is people hear that a lot, and that certainly can be done on die casting. We do it a lot for current applications. Just one thing to consider is anodize is typically not what we would consider a cosmetic appearance. On other types of processes like a CNC machined part, if you anodized an aluminum part that had been machined, that would give you a very, very nice cosmetic finish. On a die casting, the anodize just does not come out quite that well, and it's a little blotchy and not as even a finish as you might expect. So what anodize is a fantastic pretreatment, and some people are able to use it as is without a top coat. Just know that it's not really being considered a cosmetic finish. And then the final top coats, or what we would consider a lot of these to be cosmetic finishes. E-coat, which is a nice product, relatively inexpensive. It appears as a shiny black finish and pretty good coverage. Many, hundreds of different types of powder coats that can be used, whether that be a smooth or a fine texture. Many different options for that, for powder coat as well as a liquid paint options. But again, many options. Just talk with your die caster, talk with us, and let us know what you're looking for, and we can help guide you in the right direction. Just as a quick kind of reference guide to the various costs of the coatings we were talking about. We did this actually on another webinar we did a few years ago, specifically dealing with surface finishes on die casting. We went through and we took a sample part and quoted it out for the various different types of finishes that are available, and then put some charts together to show, relatively speaking, how those things compared. And so if you look at this, most of the blue sections, I think all of the blue sections, are the mechanical coatings or treatments that are available. In general, green is the chemical, and then the red is the top coat. So you can see the relative cost anything mechanically speaking is typically the least expensive alternative. Then the chemical treatments are in the middle, and then the highly cosmetic top coats are at the end. So just to give you a little reference point, again, this was done several years back, so the actual dollar amount on the left, so that was very part specific, but you can see the general trend in the graph. I won't go into this too much. This is just a quick comparison of the different surface treatments. So this was the chemical area that we were discussing. Gives a little bit of a breakdown of what the different colors will appear. Again, these are certainly not cosmetic. It's typically they're kind of a mottled look. It's not consistent, but it does show the thicknesses on the chemical treatments are very, very thin, virtually zero, to be quite honest. It's most of these are actually converting the surface of the part, not really adding thickness to it. So you can see that the thickness of the coating is basically zero. You can see which ones are RoHS compliant. Obviously, that's important. Most of the ones that are common that we use currently are RoHS compliant. There are some that are they're still being utilized that are not, but a majority of them are. And then you can see which alloys the various chemical treatments would apply to. So the Dow products are typically used on mag. Chem films are both aluminum and zinc, and then you can see the difference. So again, just let us know what you're looking for, what the specifications are, and we'll help guide you in a direction. The next quick case study, just to show, is our light systems for the dental industry. So next time you're sitting in your dental office and want to focus on something other than what they're doing to you, take a look at the lights. And most of the products that are up there, the arms and the actual backing of the lights, those are die-cast parts. They're both magnesium and aluminum components up in there. The one we're showing here is a magnesium part for our customer. Important with this was obviously highly cosmetic. Once it gets a final wet paint or powder coat, I'm not sure which one this got, but very highly cosmetic. They want it very lightweight. Obviously, they're moving this around in the room there, so they want it to be lightweight. Has to be very good at dissipating heat because that light generates a pretty good amount of heat. So this was an excellent opportunity for magnesium. It satisfied all of those. Again, the lightweight probably was the most important factor, but again, a very good part. So there's some features on this part that we did that were fairly unique. So we submitted it to the North America Die Casting Association, which is our governing industry, has contests every year to highlight new and innovative die castings, and this part actually was an award winner. So a good application. The next one we'll talk about, this is a housing for a infant warming lamp. So this is used in like neonatal care centers. And this part is an aluminum 380 alloy, and then it actually gets gold plated. So this is a real gold that gets applied to the part. Biggest factors for this part was that it needed to be able to dissipate heat consistently, which is what the gold really helps to do. Also needs to absorb light and reduce the amount of glare in the room, so that the patient and the staff are not inundated by the glare of the light. Again, an excellent application. It's actually pretty cool to see and use. So it's a very nice product that's been around for a little bit. Okay, now we'll look at a few other manufacturing processes and how they compare to die casting when you're looking at selecting a process that fits. So first what we'll talk about is machining. So many times customers will start a project, and maybe it's a lower volume project, maybe 100, 200, 500 pieces a year, and in those cases it makes sense to just machine the parts out of a billet alloy. And then when the project volume increases, obviously the cost to machine those parts start to be a pretty big factor and can start to build up. So once those volumes reach a certain level, it makes a lot of sense to look at die casting as an alternative for a cost save. If we look at a breakdown of how the process capabilities of machining compare to die casting, obviously part complexity is very, very good with machining. You have the ability to machine pretty much whatever features you want. High pressure die casting is, I would say, similar. It's not as good as machining in that category. We look at a few other items in here. So near net shape and near net shape is important. Die casting, again, what the goal is to have the part come out of the tool with as little post-processing required as possible. So that's where you get your best bang for the buck, and that's where that comes in the net shape. Material choices, obviously there's more for machining than there would be for the high pressure die cast. You can get ferrous and non-ferrous alloys in machining, and numerous grades within those. Die casting, the high pressure die casting really has the three families of alloys available: aluminum, magnesium, and zinc. There are a number of alloys within each of those, but it is typically limited to non-ferrous. Tooling costs are going to be very, very low. Tooling costs with machining, higher with die casting. But again, then when you look at the part pricing for the between machining and die casting, that's where you really get your savings. So a lot of times we're able to see customers be able to realize a payback very, very quickly when converting to die casting. If their project is in the 1,000 or 1,500 a year type numbers, the payback can be very, very quick depending on the part geometry. And then just a final summary, we talked about most of these already. The comparison between the two, die casting offers a very, very good payback from a part price standpoint over CNC machining. There is a significant amount of tooling involved typically for die casting, but again, the goal would be to make that up in the part savings. CNC machining for low volume, it's a very good option for a project. Can offer a little more range of alloys available, and again, very little tooling investment. Here's a couple of examples of conversion projects that we've done from machining to die casting. The top one is a very, very small part. So I mentioned earlier that for small parts, zinc is a great option, and the ZA8, which is an 8% aluminum zinc alloy, is what that stands for. Is a fantastic, very high strength, compares very, very well to steel and some other high grade machining alloys. But again, if you have a small part and it's a pretty good amount of volume, small zinc parts would compare very, very well. The second part is a latching component. This is a little bigger. The scale, it's hard to tell, but this is a significantly bigger part. And you can see that if you're machining this, there's a lot of features to machine out. There's a lot of wasted material that you're paying for in the billet but not actually using. So that's a disadvantage of this part as a machined part. Again, converting this to die casting was a huge cost save and a very good application for it. This next one is a pump mounting bracket. Again, another miniature zinc part conversion from machine. The challenges here was to obviously get some cost out of the system. This again was a ZA8, so the 8% aluminum, and you can see the part here in kind of the magenta or ink view here. Pretty complex, and if you're a machining this, it had a lot of features, a lot of wasted material again. So casting, you're able to manage most of the features as cast. There was a little post-machining required for some of these threads because these are pretty tight tolerance threading that was in there. But again, a very, very good cost save. This shows 20% for the entire project, and as you can imagine, that's a pretty significant amount. The next application we'll talk about, the next process comparison. Again, a lot of people will start a project or design a project with a plastic injection molding for housings and other components. And then once they get into their actual project, they realize, okay, because of drop tests or just wear and tear or EMI protection or whatever, that their plastic is just not suitable. So they look to convert it to die casting, which will offer parts that have better stiffness, impact resistance, EMI shielding ability is much better with die casting over the standard plastics. So again, if it's something that's important and your plastic part is just not holding up, then die casting may be a good alternative. Again, the comparison chart here, we'll let that fill in. Just a few things that we'll talk about. Part complexity are about equal between injection molding and die casting. What else down in here? The thin walls and variable thin walls. Die casting has a little more flexibility when looking at your wall thickness. It doesn't have to be as consistent as what injection molding typically will need. We can have thin wall and thick wall sections in the same part. It's obviously not desired if we can get away from it, but it's possible. Material choices, obviously, with the die castings, you're getting some higher strength non-ferrous alloys. So anyway, so that's the comparison for the plastics. And just the summary slide for the two. Again, for electronic components, magnesium specifically is a very good alternative for injection molding plastics from a weight standpoint, and then the added benefit of the material characteristics of magnesium for strength and conductivity and EMI that you get along with that. The last process we'll talk about from a comparison standpoint is the investment casting, or some people refer to it as lost wax. This is what I would consider an intermediate volume process. So if you have products that are a couple of thousand maybe or less, investment casting is oftentimes a very good option. You can get very good precision parts, fairly thin wall. Tooling investment is very, very low for investment casting. On the other hand, the part pricing is significantly more. So it's all, a lot of times it comes down to just an economic evaluation of where your process is or where your product volumes are to see which option may make sense. There's also, as we'll talk about in a moment, you can do more alloy choices with investment casting than you can with the high pressure die cast. So that may also be an item. So a couple things to point out, and here, if we look at the net and near net shape category, very good between both investment casting and high pressure die casting. The one thing in investment casting you can a little more easily get are undercuts. So if there are features in your part that are buried inside the part and we create an undercut, if we try to create a die cast die to create those features, where we might not be able to do that, those features as easily, the lost wax, you can achieve undercuts a bit easier. And then the alloy choices that I mentioned. Ferrous and non-ferrous alloys can be investment cast, where we're a little limited on the alloy choices. But again, just as a summary, investment castings are very, very good at lower volume projects. And then when the volumes get a little higher, a lot of times die casting is a much better economical choice. Here's a quick case study on for an investment cast part that we converted over to die casting. This ended up being a 380 aluminum alloy as a die cast part in an anesthesia unit. Again, with the challenge, we were competing against investment casting. Tooling investment for die casting was more considerable, but the part price savings that you realize, or that our customer realized as a die casting, made up for that tooling disadvantage many times over. So a good application for conversion from investment cast. So we'll just talk real briefly about some of the prototyping options that are out there for die casting. Machine from billet, that's a good option if you need maybe 1 or 2 or 5 or 10 samples, and it's a part that could be relatively easily machined. That's a good option. Rubber plaster mold, which is similar to the investment cast process, a little bit different, but somewhat similar. If you need maybe up to 100 parts from a prototyping standpoint, that's a good option, as is investment casting. There's spin casting, which is a process typically used for small parts, and a lot of times that's small zinc parts that spin cast is used for. The one thing to consider, most of the prototyping options that I list out above, you'll be using, or you'll be getting parts with an alloy that's not exactly what you'll be seeing in production. So a lot of times, if you're machining from billet, you're using 6061 aluminum, for instance, or AZ30, which is the magnesium billet alloy. Rubber plaster mold and investment cast are typically using the 356 aluminum. So you're not quite getting the same alloy that you're going to see in production. And so if you're going to be doing testing or anything that you're really going to be looking for from your prototypes, just consider that the material properties won't be quite the same. One option that we're highlighting at the bottom here, which is something fairly new, we're utilizing or partnering with a couple of our offshore partners that we have to build actual low-cost prototype tooling for die casting. And what that allows us to do is get, in a very quick time frame, maybe in some cases 4 to 6 weeks, actual die cast tooling built and parts that are produced with the exact same or virtually the exact same alloy that you'll be seeing in production. So for applications where you have to have the exact alloy that you'll be doing in production for testing or whatnot, or need some very quick turns on prototyping, we've got some very good options. So just consider that, and if you have a requirement, let us know, and we can look at that with you. But it's exciting, actually, and it's been working out very, very well. We'll talk a little bit just for the next few slides about some of the advanced inspection processes. Leak testing, we do a lot of leak testing for people. So if it's an application where you have 2 pieces that go together, or maybe that's some housing for your application that needs to be leak tight, then we can build a system to do the testing on the die castings themselves. We can either do a single or multi-cavity station. Below here you see, or to the top right, you'll see this is a 4-cavity setup where it's testing all 4 at the same time. So for high volume applications, having multi-cavity systems is a big advantage from a pricing standpoint. We do pressure decay, pressure rise, and then all of these systems have the ability to gather data to analyze later to see trends and fallout and and that type of thing. But it's for some applications, it's very, very important for the leak testing, and so we can certainly offer that for people. X-ray is another option, although we don't do a lot of X-ray analysis for customers. We certainly have the ability. This actually, it's the thinner wall parts. It's a little more difficult to do the analysis for X-ray. As you can imagine, identifying very, very small porosity holes or voids inside a casting with very, very thin walls is difficult. So X-ray becomes a little less effective in those instances. We also do a considerable amount of custom gauging for customers. Again, we could do multi-station, multi-fixture setups or a single fixture to actually systems that actually can do some very, very detailed analysis and inspection on very, very critical features. Again, data gathering to collect all that and analyze later. But just know if you've got something that's a very, very critical feature on your part, we can do some special gauging for it. And then the custom packaging, really soup to nuts for what people might need from a packaging standpoint, whether it's just going in as bulk or we do a layer pack. You can see the images here are cell packed, so each part is an individual cell. We can put individual parts in bags, and in some cases we do a completely custom solution. So it's really dependent on what your application needs, what the level of protection your part needs from the time it leaves our facility to get to your facility. So here are some of the reference materials that we'll be providing or that are available on our website that we'll give you a link to. A webinar we did a few years ago on high pressure die casting versus all of the alternate processes. We covered a few of these today, but there's many, many more in that other webinar that you can review. We'll provide a link for the NADCA die cast tooling standards and specification guide, and also a NADCA die cast tooling checklist, which is actually a good thing to go through and understand what's all involved. So we'll provide the links for you. Here's just a quick rundown of our contact information. John, Mike, and myself are on the sales team. Certainly appreciate your time listening into this webinar today. And then here's my contact information. If there's anything I can do to help, if you've got a question about an application, feel free to give me a call. This is our general sales email address, but I'll get this if you send it to that, and we'll be happy to help with any application or any questions you have. Thanks again for attending. We'll leave this presentation up and running for a little bit longer, so the floor is now open for questions. Please continue to submit them, and we'll get a response back to you as soon as we can.